Question 11 is pretty tricky. We've got an equation of an ellipse. We're being asked to determine the equation of a tangent at. Now, we don't know what k is on the x-axis, but let's say that minus 6 is here. Let's put minus 6 on the y-axis there. We've got k could either be this point or this point. So when we're trying to work out what k is, we're expecting to get a plus or minus. And because we're trying to work out the tangent, if I just bring in a ruler, the tangent at our positive value of k should be a positive gradient tangent, and at our negative value of k we should be expecting a negative value for the gradient of the tangent. Okay, so by looking at the picture, when we're beginning this question, we are expecting, when we're trying to determine y equals mx plus c of the tangent at either this point or this point, we're expecting on that journey to get plus or minus values for our x and plus or minus values for our gradient. So let's start by saying that we can find the x value when y equals minus 6. So let's have a look and see if we can find the two possible values of k that we're looking for. So let's call that find x value when y equals minus 6, and we're going to be using x squared over 18 plus y squared over 72 equals 1. Rearranging that to make x the subject, we'll have the square root of 18 minus y squared over 4. And if we put in minus 6, we'll get a value of, now this is the bit where during the rearrangement of this equation here, we ended up with x squared equals 18 minus y squared over 4. And when we square root, we get the plus or minus option here. So here we'll be getting plus 3 or minus 3 as our potential values for k. But because in the question it tells us that k is less than 0, we can cross out this one and we have a value of k now of minus 3. The next job we have is to then work out, the next job we have is that we're looking at this point here, and we now need to work out the gradient of the line of this elliptical line at that particular point. So in order to achieve that, we're going to have to differentiate this expression, dy by dx. So if we start with x squared over 18 plus y squared over 72 equals 1. Let's slowly rearrange this one to make y the subject. Y squared over 72 equals 1 minus x squared over 18. And y equals, now we'll take the 72 over to the other side, so we'll end up with 72, we'll put y squared equals 72 minus 4x squared. And then we want to square root both sides. So here I'll put it in this format because it'll help us, but it's plus or minus. So we end up with plus or minus option here. And so if we let, say for example, t equals 72 minus 4x squared, then we can write this as y equals plus or minus t to the half. We can differentiate by parts, so dt by dx would be equal to minus 8x, and dy by dt would be equal to plus or minus half t to the minus a half. And now if we multiply these two things together, we can get dy by dx as the t's cancel, and in steps that's going to be minus 8x big brackets plus or minus a half 72 minus 4x squared to the minus a half close brackets, And I tend to write this as, so when I've got a minus times a plus or minus, I tend to write this as a minus over plus for myself. Sometimes that can help me work out what I'm supposed to be doing later on. It's the opposite of what I'm thinking. Anyway, I digress. So we've got 4x over the square root of 72 minus 4x squared. And this is going to be the gradient of the tangent when x equals k and k is minus 3. Now, because it's plus or minus plus, we know from the diagram when x equals minus 3 that we're expecting the negative version of the two gradients that we're going to get. So the next job I have, I need some more paper, it's a big old question this one, is to find out what this gradient is going to be equal to when x equals minus 3. So putting that in, we end up with the gradient being equal to, so it's going to be plus or minus plus 4 times minus 3 over the square root of 72 minus 4 times minus 3 squared, and that's going to give us a gradient of minus 2 or plus 2. And because of the diagram, again just showing the diagram here, we know that the plus 2, 1 is for the positive x value and the negative 2, 1 is for the negative x value. So I'm going to cross out this one. Finally, we need to find c in y equals mx plus c when m equals minus 2, comma, y equals, what was the original question? I forget now. Y equals minus 6 and x equals minus 3. So here we'll have c, y equals mx plus c, c equals y minus mx, y is minus 6, minus m is minus 2, and x is minus 3. So that's going to be equal to minus 12 there.